talking about shapes and their cross sections. Okay, I want to make sure that you put these two definitions in your notebook, okay? So a prism. A prism is a three-dimensional figure with at least two parallel and congruent faces and bases. Okay, so go ahead and make sure that you put prism down. A pyramid is a three-dimensional figure with one base that is a polygon. Make sure that you underline or highlight prism and pyramid for me, okay? Identify the following shapes as either a prism or a pyramid. Okay, so the two distinguishing things between these two guys is that a prism has two parallel bases, okay? So two, while a pyramid only has one base that is a polygon. Okay, so a prism has two, a pyramid has one. Okay, those are the distinguishing factors. So if we look at this one has two bases, so it's a prism. This one only has one base, so it is a pyramid. This one only has one base. Oh, I wrote base instead of pyramid. Here we go. Let's write pyramid, Petruska. Same thing up here. Now this one's tricky. I want you to look at the shape, okay? Technically, his base is right here and right here, and these three squares, or not squares, but rectangles, are the sides, okay? When we look at these, we have to be careful because if they have two identical, it is a prism, okay? Even if it's not sitting on its base, maybe it's sitting on a face, then it's still a prism, okay? A polyhedron. All right, so let's look at this one. A polyhedron is a three-dimensional figure with flat surfaces that are polygons. Prisms and pyramids are both polyhedrons. Some words associated with these three-dimensional figures are edge, face, vertex, and diagonal, okay? It might be nice for you to either print out this slide or to take a few notes on this. Okay, an edge is something like this. It's along the lines that the faces, this whole thing, connect with. Okay, so a face is that flat surface. You can put your hand right on it and it should hit flush against the wall of the box, and that's the face. The edge is where the faces connect, while the vertex are where the edges connect. They come to that corner point. And a diagonal goes from one vertex straight through the prism or the polyhedron, whatever it is, the polygon, the prism, the pyramid, whatever. It's the polyhedron. It goes straight through and cuts diagonally, hence the word diagonal, through to the other vertex. There are also solids that are not polyhedrons. For example, a cylinder and a cone. Again, you might want to either print these notes out or sketch them yourself. A cylinder are those can shapes, okay? A cylinder is a can shape. Now, you can't call it a can, we call it a cylinder, okay? A cone, think of an ice cream cone. If it was flipped over, you could store your ice cream in it. These are kind of similar to our polygons, our prisms and our pyramid friends. He's related to the prism family because he has two faces that are both the bases, while the cone only has one face, similar to a pyramid, or one base, right? So when we look at them, though, do you notice that that's all they have? They only have those two faces that we also call bases, and they don't have any other straight, flat sides. Okay, so how do we identify them? A prism has at least three lateral faces that are parallelograms, okay? So rectangles, parallelograms, okay? Squares are parallelograms. The top and the bottom faces are called the bases, and they're congruent. So this guy has two triangular ones, while all the other faces are parallelograms. So therefore, he is a prism. The rectangular prism has two rectangles, or or squares, depending on the shape, but all of the faces that connect them are rectangles or parallelograms, as we like to call them. A square prism is a cube. I want you to make sure that you have both those names written down. Cube is the one that you hear most often, okay? Like Pepsi Cube. That's their marketing ploy to get you to buy Pepsi. A triangular pyramid, okay, and a square pyramid. They have at least 3 lateral faces, but these are triangles. So up here, they're parallelograms. Do you see that all the faces, except the base, unless it's a triangular one, are triangles? They have only one base that's a polygon, and the shape of the base tells the name of the pyramid. So again, there's a lot of vocab here. I need you to either print them out or make sure that you have them written in your notebook, okay? So make sure you utilize that print feature that I have on Blend Space. Identifying cones and cylinders. A cone has only one base, okay, while the cylinder has 2. Remember we talked about them? And they're both circles. The cone only has one vertex. These have no vertices, no edges. Edges have to be those flat pieces, and the vertices have to come to a point, and they don't do that. Same thing with the cylinder, or with the sphere. He has no faces, bases, edges, or vertices. His only distinction is that he's got that spherical shape, and every single point that we put on this spherical shape would be exactly the same distance from that center point. Okay, basketballs, those are spheres. All right, so take a second, pause the video, and try these. I'll be back in just a second to show you the answer. Remember, look for the bases first. Sometimes these shapes don't sit on their bases, okay? Go ahead and pause. I'll be back in just a second. Okay, so when we classify these, the rectangular pyramid has a base that's a rectangle right here. The triangular prism has 2 bases, one right here, each a triangle. The cylinder has 2 circular bases, one right here and one right here. The triangular pyramid has 1 base that's a triangle. The triangular prism has 2 bases that are triangles. The rectangular pyramid has a rectangular base and only one. The cube has 2 square faces or bases, and remember all of them could be considered the base because they're all squares. And then we've got a pentagonal pyramid. I got interrupted, so I think I said pentagonal pyramid has a pentagon as its base, and there's only one, so that's why it's a pyramid, while the octagonal prism has 2 bases that are both octagons. Okay, so cross sections are intersections of a solid and a plane, and it's called the cross section, okay? So when I take this plane, like think of a plane as being like a little sheet of paper or something, and it slices through the prism or the pyramid or whatever you want to call it, slices through the shape, okay, of your solid. They want us to describe the shape resulting from the vertical, which would be up and down, or the horizontal, which would be across, of the square pyramid. So when I cut this straight down, I can see in this dotted line a triangle. So the cross section is a triangle. When I slice it like this horizontally, I see a square. Okay, so the horizontal slice of a square pyramid is a square, and the cross section of a vertical on the square pyramid would be a triangle. All right, so try this one. Name the shape and describe the shape resulting from the vertical or horizontal section of the cylinder. Okay, if I slice this one, he is a cylinder. They told you to name it, but they kind of named it for you. Okay, so if I slice it along the horizon, we see a circle. If I slice it along the vertical, right here, we would see a square or a rectangle. Okay, and I'm going to show you that a little bit more in class. So why don't you try these? Go ahead and slice them vertically and horizontally and see if you can figure it out. We don't have to do this one because we just did it, okay? So slice them vertically and horizontally for me. I'll be back in just a second to show you the answers. Okay, here we go. If you slice something vertically, it's really the side that you see, okay? So if I sliced this up and down vertically, I would see a rectangle. If I slice it, so vertically you would see a rectangle. Horizontally, meaning like across, I would see a triangle. Okay, so I'm just going to go through, I'm not going to write each one of them and tell you what each one would be. If you sliced this vertically, you would see the triangle, and if you sliced it horizontally, you would see a rectangle. If you slice this one vertically, you would see up and down, you would see a triangle, and horizontally you would see a triangle. If you slice this one vertically, up and down, you would see a triangle. Horizontally, you would see a rectangle. If you slice this one up and down, you would see a triangle on the side, and horizontally, you would see also a triangle. If you would slice this one up and down, you would see a square because it's a cube. Vertically, you would also see a square. So up and down vertically and horizontally, you see a square. If you slice this one vertically, up and down, you see this triangle. Horizontally, you see the hexagon. Vertically, you see a rectangle, and horizontally, you see an octagon. And that's all I've got for you today, and I will see you next time.